Hello and welcome all. This is Pooja Saurus, and in this session we are going to understand a very special type of number. This is the irrational number which we refer to as surd. So what is surds? Surds is of a format nth root of a, where a is any positive rational number and n is any natural number, but nth root of a is always the irrational number. So we are going to understand two things in this session: surds and indices. When it comes to surds, the format is always the irrational number, and indices is a format which is a rational number. We will understand indices subsequently. Before that, let's understand surds and its types. There are two kinds of surds. One is a pure surd and second is a mixed surd. When we refer to as pure surd, we mean that there is one or unity as the rational factor and other being the irrational factor. What do we mean by that? Let's take example. For example, cube root of 2 or fourth root of 5. Here, directly 5, here the number involved is 1 root 2 or cube root 2. Similarly, 1 and fourth root of 5. That's the reason we do not write this number 1, but we directly write this irrational factor. Similarly, if I replace this 1 by any natural number other than 1, we make this surd as a mixed surd. For example, 2 cube root of 7 or 5 cube root of 10 or 2 fourth root of 15. So all these numbers are definitely surd, but they are mixed surd because they have got integral factor attached to the irrational number. Now, how do we add and subtract these surds? Similarly, how do we multiply or divide these surds? Let's understand. To add or subtract these surds, we need to have the like surds. For example, their power should be raised to the same, as well as the radicand, that is the number inside it, should be similar. To multiply the surds, I can multiply the surds with any other surd by multiplying the power as well as the radicand, depending on the numbers involved. But let's understand, how do we understand if the surds are greater than other or lesser than other? That means the comparison of surds. For example, if I ask you cube root of 4 or fourth root of cube, which number is the greater number? It may not be apparently so easy to calculate, but it is easier to calculate if you know this method. The method is, now raise these rational numbers by the powers. That means make these roots as raised to the fraction. So cube root of 4 becomes 4 raised to 1 by 3 and fourth root of 3 becomes 1 raised to 4. Hence, now we get two numbers, 4 raised to 1 by 3 and 3 raised to 1 by 4 to compare. So now we get two numbers, 4 raised to 1 by 3 and 3 raised to 1 by 4 to compare further. If you observe carefully, the powers are not same, neither the base, and hence we cannot actually compare it without making either of them same. Making the power same without changing the value is the right method to go ahead. So how do we go ahead about this? 1 by 4 and 1 by 3 are the respective powers of the numbers. So we need to find the LCM of the base or the denominator of the raised to fractions. So here the LCM of 4 and 3 is 12, and hence 1 by 4 is converted as 3 by 12. Similarly, 1 by 3 is now converted as 4 by 12. Now, if you take this raised to power, the numerator separately and the denominator separately, you will be able to compare the surds. That means, now 4 1 by 3 becomes 4 raised to 4 divided by 12, which gives us 4 raised to 4 bracket raised to 1 by 12. So we are separating the numerator and denominator of the power. Similarly, for 3 raised to 1 by 4, we get now 3 raised to 3 divided by 12. So now we are separating 3 and 12 to get 3 raised to 3 the whole raised to 1 by 12. Now if you observe, both the powers have become 1 by 12. So now we can compare the numbers between the brackets to get the answer. Hence, now 4 by 4 and 3 by 3. Hence, 4 raised to 4 and 3 raised to 3 gives you the answer as 64, gives you the answer as 256 and 27. So now 12th root of 256 and 12th root of 27. Which one will be the bigger number? Definitely the 12th root of 256. Hence, cube root of 4 will be greater than 4th root of 3. So this is how we compare the surds. Now there are certain laws in surds, and if you understand these laws, I am sure you will be able to crack any questions involving any power and any numbers. So as we said, how do we multiply, divide surds? These are the laws based on the radicand and the power. We can apply them and get the respective answers. Let's start. First one. Nth root of a raised to n. Nth root of a raised to n can be also written as nth root of a raised to n. That means I am taking the power of a inside. This gives me an outcome as simply a raised to 1 or a. So any power raised to as well as 1 by that power will always negate or nullify the effect, and the power will become finally 1. Example, cube root of 7 whole raised to 3. So you don't have to think further, you have to just observe that the raised to power and the root power is same, and hence the answer will be the radicand itself, which is 7. Moving on to next law, which says nth root of a divided by nth root of b. If you observe here, both the radicands of the numerator and denominator are different. One is a, second is b, but the powers of both of them are same. So I can take the whole fraction under the same power to make it nth root of a by b. Rule number 3, third law, nth root of a into nth root of b. nth root of a into nth root of b will give me nth root of a into b. This is very similar to the division of nth root of a divided by nth root of b. Here, when the power is same, that time you can take both the numbers under the same root and you can multiply them or divide them as per the requirement. Now, very importantly, the fourth law says a raised to 0. Now, a raised to 0 is 1. So, any number a, let's say 7 raised to 0, 15 raised to 0, 20 raised to 0. So, any number raised to 0 will always give you plus 1 as the answer. Fifth law of Surd says a raised to minus n, that means the negative power, a raised to minus n is equal to 1 upon a raised to n. Okay, we'll take this as the fourth law. The fourth law of Surd says if I have got two roots, nth root of mth root of a, I can combine both the roots by multiplying them together. I can also exchange the positions of m and n. So, nth root of mth root of a is also equal to mth root of nth root of a, and it is also equal to m into n, that is the product, m into nth root of a. If I do not want to change the value of Surd, but still I can multiply the Surd as well as divide it by the same power by keeping the value same. And that is what exactly is defined in the next law. It says nth root of a raised to p. So, here there are two values, one is the root, one is the power. So, nth root of a raised to p is also equal to m into n, this is the product of two numbers, m into nth root of a raised to again the product of p into m. Here we are raising the number by mth power as well as we are taking the mth root of the number, and hence it does not change the value of the initial or the original number, which is nth root of a raised to p. Now, this can be useful to make the surds like or to have some addition or subtraction between two surds, or probably the comparison between two surds. If you understand these basic laws of surds, it is easier to apply them and solve the surds as per the question. In number system, we have also taken this factor called as a rationalizing factor. Now, we are going to apply the same concept for rationalizing the surds. Now, surd is an irrational number, and making it rational means multiplying it by the conjugate. If you remember, the conjugate of the imaginary number I was change of sign. Similarly, the conjugate of surd is also the change of sign. For example, 2 plus root 3. Now, 2 plus root 3 is a number wherein 2 is an integer and root 3 is a surd. I cannot add them further, but if I want to rationalize them, I can rationalize it by using a factor which is 2 minus root 3. Now, why do we do this? We do this because there is a formula which is based on a plus b, a minus b, wherein the two numbers are added once and subtracted once. If I take the product of this, I get a square minus b square. Applying the same formula here, I get 2 plus root 3 into 2 minus root 3, which is 2 square minus root 3 square, which gives us 4 minus 3, which is 1. And the outcome 1 is a rational number. But here we have changed the value of the factor. Now, rationalizing surds can be done in different ways. For example, take only a surd, which may be cube root of 4. Now, cube root of 4 is an irrational number because I cannot have the integral cube root of 4. But can I make it rational? Yes. If I multiply it by cube root of 2, then it becomes cube root of 8, and that is, answer is 2. Hence, now cube root of 4 is changed by rationalizing to answer 2. There can be different rationalizing factors to the same. For example, cube root of 4 is multiplied by cube root of 2 into some other number or some other cube. For example, we can also multiply it by cube root of 16. So, we get cube root of 4 into cube root of 16, which is cube root of 64. Here, the answer changes from 2 to 4. So, in short, the tip here is you can have n number of rationalizing factors, but you need to choose the least possible one to get to the answer. If you have understood surds, let's move on to indices. What is indices? The indices is a simple form of a number wherein there is a base and the base is raised to a power. For example, b raised to m, where b is any rational number and m is any natural number. Or in fact, m can be any whole number, wherein the m stands from 0, 1, 2, 3 to any number. Here it is read as b is raised to m. Now, indices have got certain rules to it as the laws of surds. If you understand laws of indices also, it becomes easier to add, subtract, multiply or divide the indices. So, indices is all about understanding maybe the squares, cubes, the fourth power, sixth power, so on and so forth. So, first let's go through the laws of indices. The laws of indices, the first one, multiplication of two indices. For example, a raised to m into a raised to n. If you observe, the base a remains constant, the powers change m and n. Since it is multiplication, we can solve this by adding the powers together. So, the outcome is a raised to m plus n. Similarly, if I have to apply this to division, a raised to m divided by a raised to n. Here again the radicand or the number base is same. So, the answer is a raised to m minus n. Third one, if a is raised to any power m and the whole number is raised to power n, then I can interchange the powers. I say it is also equal to a raised to n the whole raised to m, or it is equal to a raised to m into n. The fourth rule of this says a raised to 0 is 1. That means any number raised to 0 is always 1. The fifth rule talks about the negative power. A raised to minus n. Now a raised to minus n can be also written as 1 upon a raised to n. That means the power becomes the denominator. That means the number comes in the denominator and the power becomes positive. Or else, in other case, if the power is always negative, or in other case, the power is already negative, it becomes positive when it goes up. So it is a change of sign as well as change of number from numerator to denominator. The fifth rule talks about a by b raised to m. That means here two different bases are involved, a and b, but they are raised by the same power m, wherein m is not equal to 0, b is not equal to 0. Then the same thing is also equal to a raised to m individually divided by b raised to m individually. That means I can apply the power to both the numbers individually and the effect remains the same. The next law also talks about now the two important rules which you need to understand while using this on indices. If the base is same, then you can either take them under the same root or the same power, or if the powers are same, then you can further work it out by considering the numbers individually raised to the power. And that is what we considered in the previous two rules, where a by b was raised to m, wherein you can individually separate the powers a raised to m divided by b raised to m, and in other case a raised to m divided by a raised to n, wherein the base was same, it became a raised to m minus n. Hence we can work it out, we can apply laws of indices in two cases, when either the base is same or the powers are same. Okay. Now if you have understood the laws of surds and indices, you should be able to simplify certain examples on surds and indices. So let us begin. Example number 1. Cube root of 33. Example number 1. Cube root of 32 is equal to 2 raised to x. So let's find the value of x. Now as you know, till the time I do not make the base as same, I cannot compare the powers. And hence to find the value of x, I need to make the left hand side, that is cube root of 32, as the form base of 2. Hence cube root of 32 can be converted as 32 being represented by 2 raised to 5, that is 2 into 2 into 2, that is multiplied by 5 times. Hence cube root of 32 is presented now as 2 raised to 5 divided by 3, and that is equal to 2 raised to x. Now since the base is same, that is 2, we can compare the powers, and hence the value of x is given by 5 by 3. Example number 2. 6 raised to 6x plus 6 is equal to 1. Now you may see that the powers are not same and neither the base. So how do we compare? But if you remember the law which says a raised to 0 is 1. Hence, I can write this 1 as 6 raised to 0 so that I get the base as 6 on both the sides. Now I can compare 6x plus 6 is equal to 0. So these are the comparison of two sides. 6x plus 6 is equal to 0. Hence, we find the value of x as minus 1. Going ahead to example number 3. 2 raised to 2x minus 1 is equal to 1 by 8 raised to x minus 3. Now here, if you observe, the base 2 is common, wherein the base is situated in two different positions. On left hand side it is in numerator, on right hand side it is in the denominator, and it is in the form of 8, which can be rewritten as 2 cube. Now I can compare this by making the base in the numerator by taking or changing the power of 8. From x minus 3 I can make it minus x plus 3 if I take 8 in the numerator. Now 8 becomes 2 raised to 3 and this whole is raised to minus x plus 3, which gives us 2 raised to minus 3x plus 3. 2 raised to minus 3x plus 9. And left hand side you have 2 raised to 2x minus 1. Now since the power are same, since the base is same, I can compare the powers by putting 2x minus 1 is equal to minus 3x plus 9, which gives us 5x is equal to 1 plus 9. So hence the value of x becomes 2. Moving on to the fourth example. Square root of 8 whole raised to 1 by 3 is equal to x. Now square root of 8 doesn't actually exist in the form of a rational number. Hence, we'll convert this 8 as 2 raised to 3 and the power and the whole raised to 1 by 3 now can be taken with 2. Hence, it is 2 raised to 3 into 1 by 3 and the square root of that, which gives us square root of 2. And hence, the answer is the value of x is root 2. Now, this was about the simplification of surds and indices. Let us understand more about the application in terms of rationalization and comparison of surds. Now let us use this example to understand more in detail about rationalization of surds. The example is, if 1 plus root 6 divided by 2 plus root 3 plus 1 plus root 6 divided by 2 minus root 3 is equal to a plus root b, find the value of b. Here if you observe, there is root in every term, which makes all the terms as irrational. So how do we solve this? We solve such examples by rationalizing the denominator, because on the right hand side you have a plus root b in the numerator. That means the denominator on the right hand side is 1. Hence, we need to rationalize the denominator on the left hand side by cross multiplying, because if you observe, the denominators of both the terms are conjugates of each other. Hence, the cross multiplication will make the denominator as a rational number. Let's go ahead with the solution. The denominator will be 2 plus root 3 into 2 minus root 3, which gives us 2 square minus root 3 square, which is 4 minus 3 is equal to 1. So this makes the denominator 1. Now only work on the numerator. The cross multiplication terms are 1 plus root 6 into 2 minus root 3 plus 1 plus root 6 into 2 plus root 3. Now if you observe, there is a multiplication of 1 plus root 6 with two different terms. So can I take this 1 plus root 6 as a common factor? Yes. And then combining both the terms, we get 2 plus root 3 plus 2 minus root 3. Hence, what remains in the bracket is 4. Now, we need to multiply this 4 by 1 plus root 6, which gives us 4 plus 4 root 6. But if we need to compare it with the right hand side, we have a plus root b. That means it's a pure surd. That means I need to change the form of 4 root 4 into a kind of pure surd, wherein the rational factor is 1. So let's go ahead. 4 plus 4 root 4 is equal to root of 4 square into 4, which gives us 4 square is 16 Now, once the denominator is 1, let's focus on the calculation of the numerator. Now, 1 plus root 6 is the common factor, and hence I can keep it aside in the cross multiplication. Hence, we get the calculation as 1 plus root 6 bracket 2 plus root 3 plus 2 minus root 3, which gives us 1 plus root 6 in bracket 4. So finally, we get the answer as 4 plus 4 root 6. But if I compare this to the right hand side, I get a plus root b. Here I can compare the value of a is equal to 4, but value of b has to be complete root. Hence, 4 root 6 has to be converted by taking 4 under the root. Hence, now the value changes and it becomes root 16 into 6, which is 96. Hence, the value of b is 96. Let's go to another example of comparing the values of surds. Now, given these three options, can you arrange them in the ascending order? So, before arranging, you need to understand the values, right? So, let's go ahead in understanding how do we arrange them based on their base or powers. Question is, arrange in ascending order these three numbers: 3 raised to 1 by 6, 2 raised to 1 by 5 and 5 raised to 1 by 8. Now, if you observe, none of the powers or base is common, and that's the reason we cannot compare it in a very straight manner. That's the reason I need to either make the powers common or else the base common, or bring to a level wherein I can easily compare the powers and base. So in such cases, let us make the fractions into the integers. Hence, we will find the LCM of the denominators in the fractions involved. So LCM of 6, 5 and 8 gives us 120. Hence, raising all the terms to 120 gives us 3 different terms without changing the comparative relation between these 3. Hence, we get these terms as 3 raised to 20, 2 raised to 24 and 8 raised to 15. Now 3 raised to 20 can be rewritten as 3 square the whole raised to 10, which is 9 raised to 10. 2 raised to 24 can be similarly rewritten as 2 cube whole raised to 8. That is, 24 is divided as 3 into 8. Hence, we get this term as 8 raised to 8. And finally, it is 8 raised to 15. Now, clearly you understand that 8 raised to 8 is less than 8 raised to 15. So, which number is the smallest number? We are yet to find that. Let's understand now the comparison between 9 raised to 10 and 8 raised to 15. Now 9 raised to 10 and 8 raised to 15 again can be made common by pulling out 5 factor from it. Hence 10 can be written as 2 raised to 5 and 15 can be written as 3 into 5. So 9 square is 81. So the first term becomes 81 raised to 5 and 8 raised to 15 becomes 8 cube, which is 5 and 2 raised to 5. Now you clearly see this, that the first term 81 raised to 5 is lesser than 5 and 2 raised to 5. Hence, we get the solution as answer D, which is 2 raised to 1 raised to 5, which is 2 raised to 1 by 5, 3 raised to 1 by 6, and the largest one is 5 raised to 1 by 8. So this is how you compare the surds and understand the laws of indices and surds to solve the questions easily and faster. I hope you understand the basics of surds and indices to apply in questions based on numbers, surds and indices. We'll get next to the topic called as HCF and LCM, wherein we'll also understand the application of surds and vice versa, application of HCF and LCM in surds.